Imagine looking up at the night sky and noticing something is wrong. The stars are still there, but they don't look the same. They appear slightly distorted, bent, as if space itself has been stretched, because something invisible has entered our solar system, a black hole, not glowing, not exploding, just moving silently through space. If this object came close enough, Earth would not survive, but not the way you think. Black holes are not cosmic vacuum cleaners. They don't randomly suck everything in. They are objects with mass and gravity. Everything depends on two things: how massive it is and how close it gets. If a stellar mass black hole, roughly 10 times heavier than our Sun, drifted into the outer solar system, the first signs would not be destruction. They would be orbital changes. Neptune would shift first, then Uranus. Their once perfect circular paths would slowly distort into ellipses. The solar system would no longer be in perfect balance, and balance is everything. Far beyond Pluto lies the Oort cloud, a vast shell of icy objects surrounding our system. As the black hole passes nearby, it disturbs this frozen reservoir. Thousands of comets are sent inward. A silent storm begins, but the real turning point comes if it approaches Jupiter. Jupiter is not just another planet, it is a gravitational shield. Its immense mass protects the inner planets from countless asteroids and comets. Disturb Jupiter and that shield collapses. Planetary orbits destabilize. Resonances amplify. Small changes compound over time. Years pass, then decades. Slowly, the inner solar system becomes unstable. Now imagine it gets closer still, close enough to influence Earth directly. The first visible sign would not be fire. It would be distortion. Light from distant stars would bend. Constellations would appear warped. Astronomers would detect anomalies in orbital calculations. The discovery would not be cinematic. It would be mathematical. Precise measurements would show tiny discrepancies, fractions of a degree. Models would be recalculated, and slowly the conclusion would emerge. Something massive is approaching. Tidal forces begin to increase. Gravity does not pull evenly. The side of Earth closer to the black hole feels a stronger pull than the far side. Oceans begin to bulge. Tides rise beyond anything in human history. The crust strains under stress. Earthquakes multiply. Volcanic systems destabilize. If the black hole passes within a few million kilometers, Earth could be torn apart. Not swallowed whole, but stretched and fragmented. The closer you approach a black hole, the greater the difference in gravitational pull between your head and your feet. This difference is called tidal force. At extreme levels, it stretches matter itself. Scientists call this process spaghettification. You would not explode. You would elongate atom by atom until structure becomes a thin stream of matter spiraling into darkness. But here is what most simulations exaggerate. Instant destruction is unlikely. The most probable outcome is long-term orbital instability. The solar system would not end in a single day. It would decay slowly. Collisions would increase. Objects would be ejected into interstellar space. Some planets might survive, but not in the configuration we know today. There is one more scenario. What if a black hole replaced our Sun entirely? If its mass were identical to the Sun's, Earth would continue orbiting normally. Gravity would not change significantly. But without sunlight, temperatures would collapse within weeks. Oceans would freeze. Photosynthesis would stop. Life would not end because of gravity. It would end because of darkness. A black hole would not arrive with fire. It would arrive with silence and gravity, and by the time humanity truly understood what was happening, the solar system we depend on would already be changing forever. But we are still missing one critical question. How likely is this scenario really? Rogue black holes do exist. Some of them were ejected from their original galaxies during violent gravitational interactions. They drift through interstellar space, invisible, detectable only through their gravitational effects. However, space is unimaginably vast. The distance between stars is measured in trillions of kilometers. The probability of a black hole randomly passing directly through our solar system is extremely low. Not impossible, but extraordinarily rare. And even then, distance is everything. If it passed hundreds of billions of kilometers away, we might never notice. The solar system would continue as normal. But if it passed closer, within the orbit of Neptune, the outer planets would begin to feel the disturbance. Gravity would subtly rewrite the architecture of our planetary system. Now consider an even more extreme possibility. What if the black hole captured one of the outer planets? Instead of destroying it, it could pull it into a new orbit. The captured planet would become a satellite of darkness, locked in an eternal dance around an invisible master. From Earth, the sky would slowly change over years. Familiar constellations would shift. Orbital calculations would fail. The solar system we memorized in textbooks would no longer exist. And yet, life on Earth might continue, at least for a while. That is what makes this scenario so unsettling. It is not always instant annihilation. It is instability, slow gravitational decay. Imagine generations grown up under a sky that looks slightly different each decade. Scientists racing to understand what is happening. Governments debating evacuation plans that make no sense. Humanity watching the heavens, waiting. And if the black hole finally passed through the inner solar system, the gravitational forces would peak. Planetary trajectories could cross. Mars might be thrown outward. Venus could shift inward. Earth's orbit might elongate dramatically, sending us closer to the sun at one end and farther away at the other. Seasons would become extreme. Climate systems would collapse. The planet might survive the black hole itself, only to be destroyed by the instability left behind. That is the true danger, not the moment of arrival, but the aftermath. A black hole does not need to consume Earth to end life on it. It only needs to disturb the fragile balance that keeps our world stable. And balance in space is delicate. Remove one major gravitational anchor, and everything begins to drift. So if a black hole ever entered our solar system, the sky would not explode. It would bend. Orbits would shift. Gravity would whisper at first, then roar. And by the time we fully understood the scale of what was happening, the solar system we call home would already be something else entirely.